Hi, Daniel Bowes here, and I'm just going to be going through the theorem that the distance from the focal point to any point on an ellipse and back to the other focal point is equal to the major diameter. Now if I press play on this video, we can see that the point H is following around, and these are all points on the ellipse. But as you can see, from point F to H and back to G is equal to the major diameter. We can see this because when the lines run flat across the major diameter, we can see they are overlapping here from F to H or A and back to F, and then the line goes from F to G, and in turn the double up over here would fill in this space because the two focal points are spaced out evenly from the center point, and that would then prove that the distance from F to H, which is any point in the ellipse, and back to F1 here, which is G, the other focal point, is equal to the major diameter. Daniel Bowes here, and I'm just going through a parabola and how the point on the fixed line going horizontal out to the parabola and back to the focal point, how these two lines are the same length. This fixed line here is perpendicular to the axis, and the vertex of the parabola is the same distance from this fixed line and the focal point. It is directly in between them. Now, as you can see, if we move this circle here, these two lines stay the exact same length, one touching the fixed line and one touching the axis, and the center point of the circle being on the parabola. And no matter where we move this to, this point will always stay in the center, and these two lines will always remain the same length. We can see this as well when we move it right down to the axis, how this line fits perfectly into the circle. Up and down now. There we go. You can see it fits in lovely there, and it stays going no matter what size.